Hello students, till now we discussed about signals. From this lecture, let us start systems. So first, what is a system? A system is anything that is used to process a signal. So, if there is a system, what it will do is, it will take a signal as input and produces desired signal as output. So indirectly I can tell that a system changes the properties of applied signal. Next, how do we denote a system? It is generally denoted by its impulse response, that is h of t, which is also called as impulse response. For now, just remember h of t is also called as impulse response. Why it is called so, we will discuss in further lecture. Next, we can also represent a system by using its input-output relationship. There is a system. Here, I am only interested in relationship between input and output. I am not interested in the components of system. That is, if the input is x of t and output is y of t, if I represent my system as y of t is equal to x square of t, this indicates that whatever be the input, system is squaring the input. So, I am not interested in the components of system or how the process is happening or anything. I am only interested what is the output for corresponding input. This is called as input-output relationship. So, if in a equation an input and output should be must, then only the equation will become a system. For suppose, let me write a equation like this: d square y of t by dt square plus dy of t by dt plus y of t is equal to 0. Is this a system? The answer is no. Why? Because there is no input here. Only output term is present. That's why this is not a system. So from here, both input and output should present. Then only the equation is called as system. Is this okay? Next, let us see what are continuous time systems and discrete time systems. A continuous time system is the one which is used to process continuous signal. That is, if there is a system, continuous time system, what it will do is, it will take a continuous signal as input and produces continuous signal as output, and this is denoted by h of t. Similarly, a discrete time system is one which processes only discrete signals. It takes discrete signal as input and produces a discrete signal as output, and this is denoted by h of n in square brackets. Next, let us see how to represent a system using differential equation. This is in continuous time. So this is my input, this is the system, and this is output. This is called as integrator, which integrates a applied signal. If the output of integrator is y of t, the input will be dy of t by dt. So, if I integrate this dy of t by dt, my output will be y of t. Similarly, here the input will be d square y of t by dt square. And here the signal is integration of x of t dt. And this summation acts as KCL. sum of input signals is equal to sum of output signals, that is integration of x of t dt. Next, minus dy of t by dt and minus 2y of t. Minus 2y of t. And what is the output? Output is d square y of t by dt square. If I differentiate this again, the answer will be x of t minus d square y of t by dt square minus 2 dy of t by dt is equal to d cube y of t by dt cube. I can also write this as is equal to x of t. Here the input is x of t and output is y of t. This is called as differential equation representation of system. And this is only for continuous time systems. Next, let us see how to represent the same for discrete time systems. We know that differentiation in continuous time will be converted into difference in discrete time. So here d indicates delay, that is if x of n is input to my delay block, then output will be x of n minus 1, delay by 1 unit. Here if the output is y of n, input will be y of n plus 1, and here this will be y of n plus 2, and here the signal is x of n minus 1. Let us apply the same property. Sum of the incoming signals is equal to sum of the outgoing signals, that is x of n minus 1 minus y of n plus 1 minus 2y of n is equal to, what is the output? Y of n plus 2. I can write this as x of n minus 1 is equal to y of n plus 2 plus y of n plus 1 plus 2y of n. Now I will replace n with n plus 1. The answer will be x of n is equal to y of n plus 3 plus y of n plus 2 plus 2y of n plus 1. This is the difference equation representation for discrete time systems. And this is for now. In the next lecture we will discuss about classification of systems.